Here's what nobody tells you about the sun. It doesn't just give us light and warmth. It is actively holding our entire solar system in gravitational order. Every planet, moon, every asteroid orbiting right now, locked in place by the sun's mass. Freeze the sun, and you don't just lose heat and light, you potentially lose something more important. And I've run this simulation all the way to the end. The results were not what I expected. Because the sun freezing doesn't look like a disaster movie, it looks like a Tuesday afternoon that slowly gets very, very quiet. Let me start with what freezing actually means. The sun's core burns at 15 million degrees Celsius. Its surface sits at around 5,500 degrees. In this scenario, nuclear fusion in the core stops, completely, instantly. The sun doesn't explode, it doesn't collapse, it simply ceases to generate energy. And for the first 8 minutes, nothing on Earth changes. The last light already traveling toward us hasn't arrived yet. You'd be sitting outside in sunshine, with no idea the sun just died. Before we talk more, quiz time. How long does it actually take for the sun's energy to reach Earth after leaving the surface? Is it 8 minutes, 8 hours, or 8 days? Most people think they know this, but almost everyone gets it wrong. Lock in your answer, I'll reveal it at the end. The moment those final photons arrive, everything begins. Photosynthesis across the entire planet shuts down simultaneously. Every plant, every phytoplankton, every oxygen-producing organism loses its energy source in the same instant. Not gradually, all at once. Within 24 hours, oxygen production across the biosphere stops. The atmosphere doesn't empty immediately. We have centuries of stored oxygen. But the engine that replenishes it goes silent. Permanently. Now let me talk about temperature. Earth doesn't freeze immediately. Our atmosphere retains heat like a blanket. Within about 1 week, surface temperatures drop to around -17 degrees Celsius. Within 1 year, -73 degrees. Within a decade, the oceans begin freezing from the surface down. But deep ocean temperatures near hydrothermal vents would stay above freezing for thousands of years. Life wouldn't disappear from Earth. It would retreat to the deep. The gravitational dimension is what I find most unsettling. The sun contains 99.86% of all mass in the solar system. Every orbit, Earth, Mars, Jupiter, every moon, every comet, governed entirely by that mass. Freezing the sun doesn't remove its gravity, but a cooling, contracting sun would, over millions of years, alter every orbital path in the solar system. The freeze doesn't just kill the light, it slowly rewrites the architecture of everything around it. And the sun has been fusing hydrogen for 4.6 billion years, with enough fuel for another 5 billion. And yet, every complex life form on Earth exists inside a window so precise that a change in the sun's output of just 1% in either direction would make our planet uninhabitable. We don't live on Earth. We live inside the sun's permission. Your quiz answer. How long does the sun's energy take to reach Earth from the surface? Not 8 hours, not 8 days, just 8 minutes. But here's what almost nobody knows. That same energy took 100,000 years to travel from the sun's core to its surface, before those final 8 minutes. The light warming your face right now began its journey before modern humans existed. Did you get it right? Drop your answer in the comments. I want to know.
We are a brand new channel on a mission to build our first community of 50 subscribers. If you enjoyed this simulation and want to see more, consider subscribing to help us cross that first finish line. What if instead of the moon disappearing, what if we built a giant solar ring around the moon? I already ran that simulation, and the visual results are incredible.